performance for you people that have desktops and laptops. So let's get going here. I'm sure you all read the legal disclaimer. These are our two premier chips right now at the user level. Let's not talk about servers for right this minute. The i7 Extreme and the Core i7. 3 flavors at this point. You'll see as many as 5 flavors by Christmas. Clock speeds, basic clock speeds from 266 to 3.2 at this time, going up to just brush under 4 unclocked by Christmas. Then what we'll do, first quarter next year roughly, is a 32 nanometer platform with 32 nanometer specifically designed chipsets. Okay. And if Moore's law is correct, what you will find hopefully is about 1.5 billion transistors on that little sign. Yeah? In other words, it's double the count. Core i7 basically in a nutshell is the highest performing chip we've ever produced. It's driven in an interesting way, and I think I said this last time, but I'll say it again because it's kind of fun. Laptop chips have driven our product line for several years now. With Centrino, when it came in 2001, 2002, basically everything was around a laptop designer architecture. Now we've gone back to server chips dictating our architecture. The 45 nanometer process is pervasive throughout our product line. Everything now that's produced is produced on 45 nanometer silicon. What that means is Intel can make them a lot cheaper and a lot faster throughout their entire 17-unit fabrication network. The difference between standard quad-core, Core i7, just really quickly, and we'll go through each one of these a little bit more specifically just so you're up to speed. 4 cores, 8 threads with hyper-threading as opposed to 4 and 4. Turbo Boost, which I'll talk about, DDR3 memory, which I know is a little more expensive but does perform quite a bit better, and the Quick Path Interconnect. That's the chip up there, guys, girls. That's what it looks like. On the extreme version, you have QPIs on either side. This is a picture of the standard Core i7. The reason we went to it is because front-side bus basically runs out of gas at about 1333 megahertz. We just couldn't get any performance above that with a front-side bus, so now we have Quick Path interface. Hyper-threading is back in a much improved way. I mean, we all remember Pentium 4s. The reason this works better is in the next phase. We've got more memory, we have a much wider architecture, and it really does make 4 chips act like 8. Or if there's a server chip out with 6 cores, it acts like 12. And soon you will see 8-core chips acting like 16. Turbo Boost is an interesting thing, and the real important thing is the last sentence. What we do, and what we can do, to conserve power when you're not using any of the other cores is literally turn off the dormant cores. Always before we had an idle phase, where we dropped them down quite a bit, but they were still on. Now they're off. That conserves power to a great degree, and it's instant on, it's nanoseconds. It's not something that there's any latency in. So as you go from a standard word processing document to some video rendering, pops right back on and starts performing at maximum. But in the interim, it's conserving power. That's going to mean a lot when i7s start hitting laptops. 3-cache hierarchy. The important thing there is the snoop traffic. When the CPU goes out and looks for an instruction set, it only looks at the level 3 cache. It doesn't go down to level 2 and level 1. If it doesn't see it in level 3, it doesn't look any further. Again, what that means is faster performance for you. QPI is the onboard memory controller. It is the interface between the CPU and all the other devices on board. It's faster by a ton, and it's our architecture moving forward. We won't see this yet in the lower line chips, particularly the Atom. It's got a front-side bus still, but it's coming. Power management, basically, this is where we differ and where Intel distinguishes itself over all the competition. Turbo mode is a great deal. It automatically overclocks the chip on demand, at least a factor of 1x. Now, that's the good news. Bad news is if you're going to overclock our chips, which we are now encouraging you to do, most of the ways to do that recommend that you turn turbo mode off. So a few quick statements on basically what other people have said. This is one thing I kind of urge you guys to do when you're out shopping. Look around and see what other people are saying about everybody's chips. I think we stand up quite well these days. I'm not saying that AMDs are bad or anything like that, but I think in terms of head-to-head comparisons at this time, in this time frame, and the time frame we're dealing with will probably be from now until first quarter next year, we basically have an edge in terms of performance. A little help on how to decipher our codes. The basic processors are listed this way, and then I'm going to flip over here real quick. You can look at it this way. The QX designation is the very best chip we make. If you're looking at a laptop, the P is in Paul, which is really P is in power, will give you the most current, the best performing chips. By performing, I mean better performance and better battery life. So if you're out looking and you see something with a T designation, those are the older ones. And generally they should be $100 to $200 less than the P series. But that would be the best ones out that I could recommend to you at this time. We've done some really interesting things with our U series, which are the really ultra mobile. If you notice, 11.9 watts consumption. It's really, really low. An Atom is a consumption of about 7 watts. But this is a full-on chip with dual cores and everything. In the very small Sony, and I stress this, a laptop, not a netbook, this will give you a good 8 hours of battery life. So if you're looking for long battery life alone, look to the U series. If you're looking for overall, garden variety, good performance, the P series in laptops would be the recommended chip. And if you want the ultimate, QX is our Extreme Core i7. Go down to Celeron, and we've actually improved and increased the performance of the Celeron chip to keep its competitive edge at the lower level. And that's been done recently in the past couple of months. And you'll see Celerons for the rest of this year. Whether or not they're going to survive into next year, I'm not sure. This is what I can talk a little bit about, but not a lot. This is the new, this will be the Z550 Atom chip. Codename Pine Trail. Essentially, a lot more things on the chip than are on the chip now, and there's a lot on it now. And a lot better graphics in terms of its ability to process graphics, which kind of ends that discussion we're having about netbooks not being able to do a lot of the intensive stuff. This is going to be a better step in that direction. So this is what you're going to see possibly as early as October of this year. Laramie, way out. Maybe as far as 2 years, and maybe as soon as first quarter of next year. It's anybody's guess at this point. Intel is very serious about creating a direction toward increased onboard graphics. And by increased, I mean their goal is to have an onboard graphics chip that's as good as anybody's standalone graphics card. Talk a little bit about SSD hard drives. I think we did last time as well. Everybody knows that the advantage of an SSD hard drive is lower power consumption and greater life, longevity, durability. Okay. A lot of laptops that are high-end now have accelerometers in the spinning hard drives, and if you drop it, it senses that it's going down and locks up the drive, so it diminishes the damage. But diminishes is the term. Okay. A solid-state drive is incredibly rugged and incredibly durable. Intel has done some things to increase the durability of hard drives. And you'll notice that there's starting to be kind of a pretty wide discrepancy between our pricing and some others. There are reasons for that. We basically offer an SSD hard drive right now that was tested recently against a Western Digital 7200 RPM spinning hard drive. And it was 700 times faster. Just like you're going to see a lot of smartphones with Atom processors in them as well. Intel showed, and it's been almost 2 years ago, an 80-core chip. It was cooled by liquid nitrogen. It was on a bench, not exactly a portable device, and not exactly ready for prime time, but it was out there. And I asked one of the engineers, what's that going to do for me? And he kind of smiled and said, 100% absolute speech recognition. He said, you talk to it in any language, in any dialect, do what you tell it to.